All right, Conceptual Geometry, Unit 9, Day 8. First theorem, we're going to have two theorems today. The first one, in a circle, congruent chords have congruent arcs. And this one's pretty straightforward. So what I'd like you to do, as best you can, is sketch two chords that are roughly the same length. So what this theorem says, if you've got two chords that are congruent, which means equal, then their arcs are also equal or congruent. We don't know what they are, but we know that they are equal. Using that theorem in our first few examples, this should go quickly. What I notice in this first diagram here, it tells us, well, hey, those two chords are congruent, so guess what? The arcs are congruent, which means x is 75 degrees. That's not too hard. Now, it also works in reverse. So the next example, I notice that these two arcs are equal, which means the two chords have to be equal. So in that case, x is 13. Now I can make it a little bit more challenging here. In this next example, I'm missing an arc, but I know the other arcs of the circle. So before I can verify what x is, I would have to take 360, minus 280, and that gives me 80. So this blue arc is 80, which I recognize is congruent to that arc 80, which means these two chords have to be congruent. So x equals 7. That's just an added twist to this theorem up above. Now where it's going to get a lot more challenging is this next example. It says if AD equals 8, so this chord right here is 8, and CE equals 10. So I'll use a different color. That is 10. Then find the length of BE. Well, I'm telling you right now, it's either going to be 8 or it's going to be 10. You got to figure out which one it is. So generally, when we have a problem like this, and one of the arcs is missing, we have to take all the other arcs and subtract them from 360. So let's do that. 360 minus 40 minus 60 minus 50 minus 80. So that is 130. The red arc is 130 degrees. So what we need to do now is we need to figure out, all right, the blue arc, is that 130? Or the green arc, is that 130? I think you can play around with these numbers here. 50 plus 80 is 130. So this green arc here is 130, which means BE has to equal 10. Now that's a little bit more complicated than what we've done. So there's the most challenging application of that theorem up above. Now, a follow-up to this is in a circle, a diameter or radius drawn perpendicular to a chord bisects the chord and its arcs. So it sounds more complicated than it is. Let's draw in a diameter. And then up towards the top, let's draw a chord that goes across so it's perpendicular. So I kind of like to call this the ladybug theorem because I think it looks sort of like a ladybug when we're done. This chord is bisected, so both of those pieces of the chord are congruent. The two small arcs on the top are congruent, and the two bigger arcs on the bottom are also congruent. I mean, there's not a ton of work to show for this, but when I have a chord that's perpendicular to a diameter, I have all these equal parts. And obviously you can rotate this around, so in the next example down here, it's pretty easy to see. It's the same diagram as up above, except it's rotated to the bottom. So x equals 6. Those two pieces have to be equal. The next example is a right triangle application. Find AB, so let's put an x here. Now if I notice this radius and this chord are perpendicular, so if that's 4, that piece has to be 4. And now I simply have a right triangle. So we're going to use Pythagorean theorem. That crops up from time to time in this unit. 3 squared plus 4 squared equals 5 squared. Oops, I gave it away. I already know what the answer is. Equals x squared. If I add those two up, I get 25 equals x squared. Take the square root. X is 5. All right, the next example, it says AB is 40. This is the most challenging application we have. So I know this whole length here has to be 40. It says OM, so just this piece here is 15. It wants us to find the length of the radius. Well, again, it's going to be Pythagorean theorem, but we're not going to use 40. We have to use this side here, which is 20. So we just have to be careful of that. So now when I set this up, I'll have 15 squared plus 20 squared equals x squared. All right, and I know this is going to be 625 if you throw all of that into the calculator. Then you square root it, and x is 25. Okay, and the last theorem of today, and this is a big one. If two chords intersect inside a circle, then the product of the pieces of one chord are equal to the product of the pieces of the other chord. And there's kind of a saying for this one. It says piece times piece equals piece times piece. So let's start by drawing two chords that randomly intersect in the circle. And I'm going to use lowercase letters to represent the lengths of the different pieces. So maybe I'll use an A and a B for those two pieces, and then a C and a D for those two. So the reason we call this piece times piece equals piece times piece is because in one chord, I'll highlight one chord, this one, those two pieces, if I multiply them together, A times B, has to equal the product of the pieces of the other chord, C times D. Now, if we know that, then these problems become pretty simple. We just create an algebraic equation. You end up dividing by number. Boom, there's your answer. All right, so let's take a look at a few examples. There's not much variation in these examples. So as long as we apply that, you're going to know it's very similar type of equations. In this first circle, again, you just want to identify the pieces of one of the chords. So I've got an x and an 8 for those two pieces. And then the other chord, I have 4 and 10. To create the equation, I like to use my x side first, but you don't have to. So I have 8 times x equals 10 times 4. Most of you might be able to do this kind of in your head and go right to 8x equals 40. And you just divide by 8. So in this case, x equals 5. For the sake of notes, I'm going to write out this equation every time. But like I said, some of you might be able to do that part in your head. That's fine. I just want to make sure you know where I'm getting this information. So go through these kind of quickly. The next one, make sure you get the two pieces of the same chord. That's the only thing that's critical. 10 times x equals 6 times 5. So 10x equals 30. Divide by 10. X equals 3. It's pretty easy to check, too, if you put that back into the circle and do, 3 times 10, well, that's 30. Yeah, of course it's 30 because 6 times 5 is 30. So it's a good way to check it. And then the last one, get the two pieces of the same chord. I like to start with the one that has the x. So 8 times x equals 4 times 16. Numbers are getting a little bit bigger. So calculators are for. This will give me 8x equals 64. Divide by 8. X equals 8. All right, the last example is what I would call a big circle question. On your exam will be, the 4 or 6 point question at the end of the exam. It says quadrilateral ABCD is inscribed in circle O. AD is a diameter. I love diameters because they cut a circle in half. So I know on this side of the diameter, I have 180 degrees. So the green arc is 180 degrees. And then on this side of the circle, I have 180 degrees. It says B is the midpoint of arc AC. Oh, midpoint means the middle point. So B, right here, is the midpoint of that arc. I know arc AB and arc BC are equal. Even though they don't look it, it's not drawn to scale. And then I know the measure of arc AB to CD is 2 to 1. So remember what we do in that case, we make it 2x and 1x. So AB would be 2x. And CD down here would be x. Well, there's just one more thing that we have to add. They're making this really confusing. Since B is the midpoint of arc AC, if AB is 2x, BC is 2x. And now I'm going to use the fact that all of those arcs have to add up to 180. So I've got 2x plus 2x plus x equals 180. 5x equals 180. Divide both sides by 5. That goes in 3 times. 36 is x. So now, if x is 36, arc DC is 36 degrees. 2 times 36 is 72. And then that one's also 72. So the first question, find the measure of arc CD. We already did it. That's easy. That's 36 degrees. Now I need some angles. Find the measure of angle BDA. So let me trace it. BDA. Now on your summary sheet, you should recognize this. This is the second type of angle we did in this unit. That's an inscribed angle. And an inscribed angle is equal to half its arc. So if you follow it across, here's its arc, 72 degrees. So to calculate that, you take half of 72, or 72 divided by 2. That's 36 degrees. And then the last one, angle BFC. BFC. Well, again, I'm hoping you guys can recognize that's inscribed. It's equal to half its arc. Well, what's its arc? Oh, it's that one right there. Also 72. So once again, you have half of 72, which is 36. So these two follow-up questions aren't too bad. It was the initial setup that was the confusing part. And that concludes lesson 9.8.